Next we have rotate right. Okay, what happens in rotate right is just the last bit LSB content is wrapped and brought and it is placed in the MSB position, and this all content starting from the 31st bit to first bit is rotated in the right direction, that is this way. Okay, let's see how exactly it happens with an example. So our instruction is R1 has a value 96. Let's write that down. So all these values will be 0. This is nothing but R1. Okay, so in this particular situation we want to perform a rotate right 3 times. You know, whenever there is a rotate right operation being performed, this will be brought and placed in the first position and entire content should be shifted to right. So what will happen here? You will get something like 1 1 0 1 0 0 1. All this will be filled with 0. Okay, and the last bit comes to the first position. This value is 1011, which is nothing but B, and this value is nothing but 4. So 4B and all these are 0. This happens in case of rotate right by 1 bit position. What is the result for rotate right by 2 bit position? Again rotate this entire thing. LSB comes to MSB. Entire thing should shift here. 1 0 0 1 0 1. Okay, so what is this answer? This is nothing but 5 and this is nothing but 2, and here you have 1 0 0, which is nothing but 8. So 8. Okay, so this is the intermediate answer, but our answer is ROR hash 3 is what we want, that is rotate right by 3 bit position. So what will be the answer? 1 1 0 0 here, and in this case you will get 0 1 0 0 1. All this will be 0. Okay, so what is this? This is nothing but C. What is this? It is nothing but 2. This is 1. Okay, 0 0 0 0 0 1 2. So this is the answer which will be stored in the register R0. Okay, and if in case in this instruction we had something like move S, then what would have happened? The last bit which is shifted and brought to the first position, that is this 1, would have been stored in the carry flag. Because here result is not 0, that flag will be 0, but because MSP is 1, N will be set as 1, and because overflow is not generated, so V will be set as 0. Okay, so let's now move on to the next part, rotate right extended. So in this particular position what happens is, whatever is our initial value, when you try to rotate it, okay, C, that is the carry of CPSR, becomes part of rotation. That is, the LSB bit is now shifted to the carry's position. Content of carry will be rotated and brought to MSB, and all contents present here is rotated to the right side. Okay, so this is what happens when you perform rotate right extended. Let's see that with an example. So initially let me take a very small value in register R1. Okay, let's assume you have an instruction something like this before this instruction, so R1 is 3. Okay, so now let's assume C value is previously 0. In that particular case what will happen is nothing but, now if you perform one particular rotation as expected here, so this content, okay, so this should be rotated and placed in the carry, and this is what is expected to happen. So if this is 1 and let's assume initially carry is 0, so what will happen after the rotation? Okay, so this what it will result into is R0 will get a value 1 and C will get a value of 1. Okay, Why is that the case? Because C is part of rotation. The LSB bit here was 1, which gets shifted to C, and the C content is now acting as MSB because it was 0 here, it is 0 here, and other content just get rotated to right side. Okay, that is what is happening here.